All right, units. These are very important. They will tell you almost everything. You just have to listen to what they have to say. But to be able to hear them, they have to actually be into your calculation. So in face-to-face classes, when someone asks me for help with the problem, where are the units is almost always the first thing I say, and that usually goes a long way to solving the problems. So we're going to talk about here something called dimensional analysis, and that is looking at units to help you with a calculation. And this is a very powerful technique. I more or less got a physics minor in undergrad by learning to do this reasonably well. And dimensional analysis is based on the fact that units can be treated like numbers, at least from an algebraic standpoint. So let's talk about this. Abstractly, consider thing 1 being the same thing as thing 2. Now, you could also say thing 2 equals thing 1. But if that is true, what is thing 1 divided by thing 2 equal to? Well, hopefully you remember that anything divided by itself is simply 1. And likewise, the inverse would be exactly the same thing. So thing 2 divided by thing 1 also numerically equal to 1. The other thing to know is the other really important math thing. What is anything times 1? Pretty much the same thing, right? This, believe it or not, is all you need to know for dimensional analysis. The rest is merely application. So consider this. So now here, the first application, the simplest one, is to convert the units for the same quantity. So for example, 1 inch is equal to 2.54 centimeters. Statements such as this are very important. They have a name, at least in my classes they do. And it is an equality statement. In saying that one thing is equal to another. So this tells you that 1 inch and 2.54 centimeters represents the same length. It's just expressed in different units. Now, statements such as these guys, the fractional versions, the expressions that are equal to 1, are very important, and we call these conversion factors. So it is these two factors will allow you to convert between inches and centimeters. One way, one the other. So let's talk about how that would work. So we're going to convert a length of 5.67 centimeters into inches. Now, this is also a very important string of characters for this class and for, well, life in general. And that's these conversions have the same scheme. You're starting with some starting point, the value in some original unit, and then it's multiplied by a conversion factor, and the answer is going to be the value in the new unit. And almost every single problem that you do in this class is going to have this basic form. You might need more than one conversion factor, but this is really important. Starting point, conversion factors, your end answer. Now, last slide, I gave you two conversion factors. One was 2.54 centimeters over 1 inch, and the other one is 1 inch over 2.54 centimeters. And the answer is, the question is, which one do you use? One is appropriate, the other one is not. The units will tell you that. let's say that if I picked the first one, the one on the left. So, and I would recommend that as you start doing this, write everything as a fraction. So here's the starting point. Here's your conversion factor. And before you even crunch the numbers, crunch the units, right? And so the rule is that, so again, so here we're looking at centimeters times centimeters in the numerator and inches in the denominator. So this answer, this setup gives us answers of, or units of centimeters squared per inch, which is not what we wanted. We wanted something that should be in inches. So if your setup doesn't give you the right units, there is absolutely no way that that is the correct setup. So let's try the other one. Let's see what we got here. So now we have 5.67 centimeters times 1 inch over 2.54 centimeters. Now here's the idea is that, you know, the units can be manipulated like numbers in that if something is divided by itself, it cancels out. So centimeters in the numerator, centimeters in the denominator cancel each other out, which just leaves us with inches. And so if your setup gives you the right units, there's a good chance that's the right setup. It's not a guarantee, but it is a really, really, really good sign. And then once you do that, you can just go ahead and crunch the numbers. You know, so we've got 5.67 centimeters times 1 inch over 2.54 centimeters. And that's going to give us 2.13 inches. Now, what are these ones here? I find that when you're starting out with this, it's best to write things explicitly always as a fraction. And that will that'll make it a lot easier to keep track of what's in the numerator, what's in the denominator, and what's going to cancel out what. And in cases where if there isn't an explicit denominator, just put a unitless 1 in there, and that will allow you to keep things kind of all on the same line. You don't need to do it, but I found that it has been helpful for students in the past. Right. One complication, what I call higher order units. So these are like things like cubic meters or cubic centimeters. The example I'm going to talk about here is area. So area is defined as length times length, or so it has units of length squared. And let me ask you a question here. So hopefully at this point in your lives, you know that 1 foot is equal to 12 inches. And if that is the case, could I say that 1 square foot is equal to 12 square inches? And think about that. If you know, I think you should have an idea of, you know, about how big a foot is, right? An inch is about the size of the length of your thumb from the, you know, from the last joint all the way to the end. So consider 12 squares that big in a square foot. Are they more than 12 of them? Yes, many more. So that's not right. So does that mean you have a whole bunch of different conversion factors for square feet to square inches, cubic feet to cubic inches? Well, no. You can construct the conversion factor quite easily from the one that you do know, the fact that 1 foot is 12 inches. How do you do that? Simply raise the conversion factor to the appropriate power. So now I've got 1 foot over 12 inches. The whole thing is squared. And then what happens here is that that squared is applied to everything, the numbers and the units in that expression. So that means that 1 foot over 12 inches squared is equal to 1 squared feet squared over 12 squared inches squared. And to make that a little more palatable, 1 squared is 1, and 12 squared is 144. And this has actually given you the conversion factor. And if you want to work backwards, this will tell you that 1 square foot is equal to 144 square inches. But you don't need to remember this, because all you need to do is remember this one and raise it to the appropriate power. So let's do an example. You could measure a room to have dimensions or an area of 5,824 square inches. And you know that 1 feet, actually, this is incorrect. Put my squares here. And so here these square inches cancel out. And that will give me an area of 40.4 square feet. All right, so be on the lookout for this when you're talking about things that have like a square or a cube in their units. And the last thing about dimensional analysis that makes it an incredibly powerful technique, you might think that, being able to convert from one set of units to another, whether it's centimeters to inches or square inches to square feet, is not a super duper useful thing. But here's where dimensional analysis gets incredibly powerful and incredibly useful. That you can use conversion factors or that same construction to actually equate or relate different things that are not necessarily the same quantity. They're not necessarily 2 lengths or 2 areas or 2 temperatures. And you're probably more used to this than you think. The mileage in your car is an example of this. So if you had a car that claims to get 32 miles per gallon, that tells you for that car 1 gallon of gas is equivalent to driving 32 miles. And from this equivalency statement, you can make 2 conversion factors. 32 miles per 1 gallon, so that would be the mileage that you normally talk about, or its inverse, 1 gallon over 32 miles. And this will allow you to convert between gallons of gas and distance driven for that particular car. So with that in mind, tell me, Las Cruces is about 203 miles from the Valencia campus. So tell me, with this particular car that gets 32 miles per gallon, how much gas you would need to drive that 203 miles. We had time to think about it. And what's the setup? Now remember what I told you about what conversion factor problem setup looks like. So we've got a starting point. We've got a conversion factor. And the answer. is the setup probably right? No. Let's do the dimensional analysis. So miles cancel. That gives us gallon. We're hoping for a volume of gas as the answer, so that's a really good chance that that's the right answer. And so with that particular car, you would need 6.34 gallons of gas. Actually, to sig figs, what would it be? It would be 6.3. So 6.3 gallons of gas to get from Los Lunas to Las Cruces.